Hi everyone. So in the introduction video to the exponential models, we went through the 3 different formulas. There's more, and we're going to learn a couple more, so don't think that's it. But with the models, we're going to really look at how we can write equations using the models. So I'm on page 11 of your notes. I'm going to start there. I'm going to go do a couple of different examples and then leave some for you to practice as well. So suppose the cost of a hamburger is $4 and has been increasing at the rate of 9% per year. Use the above model to find the cost of the hamburger. So the model we're going to use is y equals a sub 0. Actually, I'm going to switch from using y. We're going to use function notation. Usually with exponential, you really want us to get into this habit of using proper letters. So like here, I'm using, it's a cost function or a price function. So I might use p of t. Okay, so p of t, a sub 0, 1 plus r, 1 plus or minus r to the t. All right, so if we're going to write a function here for the price t years from now, it would be p of t. My initial amount is $4. My rate is 9%, so 0.09. So that would be 1.09 to the t power. I'm adding 1 immediately. 5 years from now, that would be p of 5. So 4 times 1.09 to the 5. Now, when doing this calculation in your calculator, it's really important you follow proper order of operation. So exponents comes before multiplication. You cannot multiply the 4 times the 1.09 first. You have to do 1.09 to the 5, then multiply. Try that on your calculator, and you should get $6.15. So that $4 hamburger today would be $6.15 in 5 years. 18 months from now. Okay, this is, why we learn about rational exponents. So 18 months from now would be 3 halves or 1.5. So p to the 3 halves equals 4 times 1.09 to the 3 halves. Now, because it's a calculator issue, I could write that as 1.09 to the 1.5 because 3 halves is 1.5. Okay, so 18 months from now, that $4 hamburger is going to be $4.55. Okay, not that hard. You're just really plugging in information. One way to make these like really simple if you want is to make yourself a little list and plug in what you have and what you need. Let me get that out of the way. The p of t, the 9%. So p of t. So, I knew a sub 0 was $4. I knew r, it was 0.09. The time I knew, was 5. And so you'd be looking for p of t. That would be like your unknown. Okay? All right, let's keep going. All right, I want you to try the first example, decide which form you're going to use, and then try it. Okay, I'm going to look at example 2. Example 2, you can see you purchase a car for $28,000. The car loses 20% of its value. Again, here's that percentage. So that's that main model, the primary model. So the value of in t years would be equal to my original amount, my initial amount, $28,000, 1 minus 0.2 because it loses value to the t. I'd simplify that to 28,000 times 0.8 to the t. So now I can look here and I can see its decay, right? And that's where that decay comes into play, okay? Again, but it was going up by a percentage, not by a decay rate or growth rate or decay rate. So I'm going to use a decimal. What's the value 5 years from now? I'm going to do v of 5. So that would be 28,000 times 0.8 to the 5 power. Okay, I'll let you calculate that. I don't have my calculator with me right now. All right, let's look at a different example and how we can kind of put this all together, okay? So in this next example, I actually gave you the equation. Suppose that today you invest some money that grows to the amount A of t equals 1,000 times 2 t over 10 in t years. Which form is this in? Well, I want you to notice that the exponent is a fraction, so it's really of that form, a of t equals a sub 0 b to the t over k, okay? All right, so you can see the b is not a percentage. It's a whole number. We would say that this is exponential growth by a factor of 2. Now, that is a percentage. It's actually 100%. But that's the form it's in. So what was our initial investment? That's still our a sub 0, so $1,000. But how long does it take your money to double? I'd like you to predict what you think the answer is by looking at the equation. How long does it take your money to double? All right, I'm giving you a second because I really did want you to think about it. Think about what it means to double 1,000. Double 1,000 would be multiplying it by 2. So that means, when is this just going to be 2? Well, it's going to just be 2 when I have a power of 1. To get a power of 1, t would have to be 10. So how long does it take your money to double? It would take 10 years for your money to double. Hopefully you're seeing that. That's the K value. If you go back to the formula we talked about earlier in the earlier video, I said the K was the amount of time it takes for a sub 0 to be multiplied by b. Multiplied by b. So think about that now. Okay? It takes 10 years for a sub 0 to be multiplied by b. Hopefully that's kind of coming together for you. All right. But that's not the growth rate. Okay? The growth rate is an annual rate or percentage that something is growing. Okay? All right. Well, first we would take 1,000, take our formula. And we want to get it in an equation that has the r in it. So I want to rewrite it as the basic model using r, which is a of t, right? This is a of t. A of t equals a sub 0, 1 plus r to the t. How would I do that? Well, I can use the laws of exponents. So first I'm going to rewrite 2 to the t over 10 as 2 to the 1/10 to the t power. Power to a power multiply. So I'm just kind of, again, working backwards. Okay? If I evaluate on my calculator 2 to the 1/10, I'm going to get, and you should try this, 1.072 to the t. So you can see these are actually equivalent expressions. So what's my annual growth rate? My annual growth rate is 7.2%. Again, the question said, how long did it take it to double? To double the money, it's going to take 10 years, but each year it's going to be going up 7.2%. Okay, so hopefully you can see how I did that and maybe try one on your own. Okay. All right. I really would like to have you try that on number 4. And, go ahead and check yourself on the note packet. The last thing I want to go through is I'd love to look at half-life. So if you jump to number 7, a few pages away in your notes, half-life, again, here's a great example. Half-life of a radioactive isotope is 4 days. That means that isotope's going to be cut in half after 4 days. This means half the substance decays in 4 days. So again, it's important to know it's a decay function, but I love us to think about the formula we were looking at, which was n of t equals n sub 0, amount of the original amount of the substance, times half times t over t to the t sub 1/2, which just means the half-life. So if I'm writing a function using this, the half-life is 4 days. So that's t sub 1/2. Okay. All right. So my equation would be n of t equals 3.2 times 1/2. To the t over 4. So now that really should look like y equal, or n of a of t equals a sub 0 times b to the t over k. So how much will be present in 4 days? Well, in 4 days, we let t equal 4. 4 over 4 is 1, so 3.2 times a half, which would be 1.6 of whatever, milligrams, kilograms, whatever. How much will be present in 20 days? Well, in 20 days, we would let t equal 5, so that would be 3.2 times 1/2. So 20 over 4 would be to the 5 power, which is about 0.1. These were in kilograms, so kilograms. Okay. All right. What's the daily decay rate? Well, the daily decay rate, we have to think about it in the form that has a rate in it. So I have to think about a sub 0, 1 plus or minus r to the t. Since this is decay, I'm going to be using 1 minus r. So again, I'm only really focused on this part of the equation. So I'm going to take 1/2, use the law of exponents and rewrite it to the 1/4 to the t power. I'm going to evaluate 1/2 to the 1/4, which gives me 0.84. Okay, so that's this part, right? 0.84 is that part. Now, you have to remember, it was actually 1 minus r that is equaling 0.84. So I'm going to subtract 1. I'm going to get negative r equals negative 0.16. So r equals 0.16. So our decay rate, our daily decay rate is 16%. So it is decaying 16% per day. All right, so that's how the 3 equations work. Hopefully that was helpful. My suggestion is for you to go through up through page 14 and do the other 5 examples that are on those pages and check your answers on the solutions guide to see if you did those correctly and bring any questions to class tomorrow. Okay? Have a great day.